All right, well, um, this is going to be our first section of notes on transformations. We just worked on coordinate plane, right? How to graph different points on the coordinate grid. So that's going to be essential here for when we work with transformations. This first one is going to be translation. So what is a translation? It is shifting points, lines, and shapes on a coordinate plane. Right, so that's just right taking. I'm just gonna draw a point here. That's just taking a point and just dragging it. Right, it's not rotating. It's not reflecting. It's just staying as is. Just changing position. So what does that look like in our specific notation here? We have our pre-image and our image. The pre-image is any point, so any point x and y. This t right here is just notation just to say that we are translating any point, any ordered pair on the coordinate grid. So that's the pre-image, that's before we perform a translation. And we have the image, which has some type of value constant with our ordered pair. So as we see here, on the right side, we have x plus a. This a value, this a value shifts either left or right. If this value is, let's say, instead of a, I'm going to say 3. So if this were x minus 3, it would shift the pre-image 3 to the left. If this were x plus 3, we'd shift this 3 to the right. And then similarly, we'll go with the y value, depending on its sign. This will shift it either down or up. Down if it's a negative value, up if it's a positive value. We have a couple of examples here, some with a grid, some not. But let's go and get started on our first example. So this first example says shift any point, but this is going to be 5 units down. How does that look like in our notation? It says we're going to translate any ordered pair. And the 5 units down part is actually right here. This y minus 5. The height of that is going down on the coordinate grid. Before I give us an example and an image here, I'm just going to draw an arrow on the grid, anywhere on the grid here. You don't always have to do this, but I think this is a good visual here. Let's go 1, 2, 3, 4, 5. So I'm going to draw any point here, and it should go down that many units, down 5. Let's say we're just using a point. Let's say that is right here. Right, that point is, I'm going to write it off to the side. We'll put capital T. And this is negative 4, comma 2. All right, well, if we plug in negative 4 for x and 2 for y, we're going to get this off to the right. So instead of x, we're going to have negative 4. Notice how nothing is with x, so that means we're not moving at all left and right. That x value is just staying. And then we have y minus 5. So we're going to, instead of y minus 5, we're going to have 2 minus 5 because the y value is 2. From here, we can simplify. We'll get negative 4, comma 2 minus 5 is negative 3. Right, so this way off to the left is the algebraic way of figuring out what is that new ordered pair. And we can graph the ordered pair. Negative 4, negative 3. From the origin right here, we'll go 4 left and 3 down. So 1, 2, 3, 4, 3 down. 1, 2, 3. That point's going to be right there. Let's say that this point was A, going 3 down. This is now A prime. And if we look at our arrow here, we should see that we moved down. Yeah, we moved just about down 5 units. So that's just further proving. If we plug in a point, same thing. If I just take A and I just count down, perfectly fine. So we won't always have a grid. So that's why for example 2, we just have directions. And many times in pre-algebra, you don't use this type of notation. Sometimes you'll see it, but many times it'll just say this. It'll just say shift it, this left, this right, this up and down. And we'll see that for example too. So it says shift the order pair to 7, 3 units left. We see that right, the 3 units left. It's right over here. Since it's negative, that means it's going this way. The y value, nothing's happening with that. That'll stay the same. So let's plug this in. This will be instead of x, this will be 2 minus 3 instead of x minus 3. Instead of y, we're going to have 7 right there. We can simplify this. 2 minus 3 is negative 1. And we keep that 7. Nothing happened with that. So the image of this translation of moving at 3 left is negative 1, positive 7. We're just plugging in the points and performing the integer operation from there. All right. So these first two, they're just shifting in only one direction. Example 1 down, example 2 move to the left. Now we're going to go to example 3 where we are shifting it in multiple directions. So that's going to, we're going to have to process this a little bit more carefully. It says shift 4 units right and 5 units up. And for this one, I'm going to give us, instead of a point, let's do a geometric figure. We'll say a triangle. 4 units right, 5 units up. Let's go with a triangle. I'm going to graph a point at negative 3, negative 2 right here. We'll have this is 1, 2, 3, negative 4, negative 4. And we'll also go with this. This is 0, negative 4. All right, this is A, this is B, this is C. So triangle ABC. Okay. So this is saying move everything 4 units right and 5 units up. So let's draw that arrow so we know what it looks like. I'm just going to put a point here at the end, 4 units to the right. So I'm going to count 1, 2, 3, 4, and then 5 units up. Whoops. 1, 2, 3, 4, 5. All right, let me go and graph that point. I think it's right over here. So we should have an array where each point is moving that specific direction and that distance as well. I mean, we can just take each value. Let's not make this harder than what it needs to be. Let's just take each point and count 4 units right, 5 units up. So 1, 2, 3, 4, 1, 2, 3, 4, 5. This is where A prime is going to be. Let's go with B. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. I believe that was right here. We'll have that B prime. Let me get rid of this. Whoops. All right, and now C prime. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right. That is right here, C prime. So we don't have to really perform any like algebraic computation with integers. We just count. So this is the sliding or the shifting of, in this case, a geometric figure. All right, so let's go and see if this checks out. All right, did everything move this specific? So A, yeah, A looks like it moved, right, 4 right, 5 up. B, yep, B prime pretty much matches up. And C prime, yep, everything matches up. We can tell just by the array that we drew. All right, and then finishing up our notes, let's go to the back side. Now we're just gonna take a point, and just 1 point, and we're gonna shift it 6 units right. We see that right here. And 5 units down. We see that because the y has a negative 5. All right, so this is going to look like, actually let's draw our skeleton. Our skeleton is going to be the image without any variables. So x plus 6, I'm just going to put a blank and then a plus 6. Instead of y minus 5, let's put a blank and then a minus 5. I'll plug in what our pre-image is, which is 9, negative 3. So 9 goes here, negative 3 goes here. We'll have to be careful with our operations. All right, 9 plus 6 is 15. And negative 3 minus 5, remember when they have the same sign, you add them and keep the sign, right? Owing someone $3, then owing someone owing someone $5, altogether you owe them $8, so that is negative 8. All right, so that is our image, 15, negative 8. All right, that's going to conclude our notes. From here, you're going to go to Map Accelerator. For those students that aren't familiar, you'll have to go through Clever, click Map Accelerator, and there should be an assigned skill or assignment. There should be 2, translating points and translating shapes. All right, let me know if you have questions. You're always welcome to email me. Have a good day.